Hi, my name is Mark Williams, and I did the Flyweight pattern. So an overview of the Flyweight pattern. The Flyweight pattern is a software design pattern that can significantly reduce the amount of memory a program uses. It's an example of a structural design pattern, meaning it is an example of a pattern that is used to assemble objects into more efficient structures. And it splits object state into two parts, intrinsic and extrinsic state. Intrinsic being shared between all objects that it's shared with, and extrinsic being unique to itself. The intent behind the Flyweight pattern is that it allows you to create many more objects than you would normally be able to render by sharing part of the state between objects. This way, the state doesn't have to be created from the beginning for every object. And the primary way this is done is through the concept of intrinsic state. This is the data that's passed through every object of the shared type and doesn't change between them. This pattern is intended to be used in applications where a very large number of objects must be rendered that will be similar to each other, such as bullets or trees in a game. In the state, the intrinsic state is stored inside the object from its creation, and it is shared between all objects that descend from the initial object type. An example would be bullets in a video game all sharing the same image, and the extrinsic state is unique for each used object. It is passed from outside the object and given to it. In the same example, it would be like the bullet's velocity and direction would be extrinsic and unique to each bullet instance. When to use. This pattern should be used when you have a large amount of repeating objects that are able to share a large portion of their state, and where performance and memory usage is critical to the application. In some applications, like video games, a pattern like this will be necessary to control the RAM usage. And if these conditions aren't met, the pattern may just add needless complexity to the program. So here's our UML diagram for the program we created. The Flyweight in this program is the tile type class. It's where the intrinsic state of the object that is shared between all the objects will be created. In this example, name, symbol, and the walkable boolean are intrinsic to every tile object. And the tile object is what contains the extrinsic state of the objects. It shares the state from tile type but adds additional unique data to the object, which in this example would be like a unique X and Y coordinate to the object. So tile type might create a grass object in our world, and that object could be repeated 1,000 times, and it'll always have the same name, symbol, and walkable as true. But the actual like X and Y coordinate of the tile itself is going to be different for each of them. And then the tile factory is what creates our tile objects. When we pass a symbol to the tile factory, it generates a tile of the specified type. If the type of object requested has already been created, the factory will return an existing one rather than creating a whole new object. And our world class requests the given tile type and uses it in mapping the terrain of the world we're going to create. Okay, so tile type. Here's our tile type class. Having the string name, character, symbol, and the boolean walkable. So each the constructor is going to pass all of these to every object. And then we have the tile class, which is going to give the tile type a particular X and Y value. And then the tile factory takes the tile type and takes a character symbol to create the certain type of object that it's going to create, be grass, water, mountain, or tree. And then our world class creates an array of tile objects that will act as a map of the world, and then taking a random character type character and passing it into the tile factory to generate a certain tile object that is then placed inside the map and printed out. And then here's our main, where we initialize the factory and the world of a certain size. Here we're doing a 100 by 100 size world, and then print the world, which is going to give us this grid of different terrain types. And you can see at the top that it's created one tree object, one grass object, one mountain object, and one water object. And then these are reused throughout the world, just randomly generated in this grid. And so a total of 100 terrain tiles are created here, but only 4 different objects are actually created using the pattern. And then here's just another example with a 100 by 100 size map. And we've created 10,000 total tiles, but still only 4 flyweight objects. And that is